do the class all over again. Reminds me, I took, when I was in grad school, I took a year-long course in mathematical logic. And our professor for the first 2 quarters was from Japan, and he literally could not speak English. So we spent 2 quarters sitting in class. Now, luckily, mathematical logic is mostly just symbols anyway, so he really didn't have to speak too much English. But then he went back to Japan after 2 quarters, and for the last quarter, we had another professor, and he came in and sort of quizzed us like, what do you guys know? And he was appalled because we were way behind. So he made us start coming in on, this is graduate school, right? We're not like freshmen. He made us start coming in on Saturdays for 4 hours a Saturday to catch up because we were behind where he thought we should be. So that was the class, the very last week, we got to the point where we actually understood Gödel's proof of incompleteness. Like literally actually understood it in a very deep way. And, then like a week later, it was all gone like a dream. So we spent a year building up to where we could understand this one theorem, and it was fantastic. It was like, I can understand why people get addicted to higher level mathematics. It's like a jolt of adrenaline. All right, so let's take a look. Last week, we set up our business scenario. We have our prestige worldwide. Now, I didn't see anybody laughing at this name, so.
I got it day one, dude. I just didn't want to say anything if it was like legit.
So the people in India probably aren't as familiar, but it's from a movie, and you can Google the name and you can have a laugh. It's from a movie called Step Brothers, and the two stepbrothers are complete idiots, and they start a company called Prestige Worldwide. So I used the name of their company. So we did language translation, we did language detection in our class, and then in the homework we expanded that to categorization, queue assignment, and prioritization. So we've got these IT tickets coming in. We're getting 1,000 a day, and it's overwhelming it's overwhelming the team. We got to translate everything into English. We're getting stuff in different languages. So I'm gonna just kind of go through the homework part, and then if people have done it a little differently, we can talk about that too. So hang on just one second. Let me clean up my screen here. Make sure I just showing the one thing. All right, better. All right, so we'll go through, because I think in this case the homework is kind of important to what we're going to do next. So I want to just discuss how I approached it. So just to review, we had our couple of helper functions, and then we had this function which we used to call the LLM using an SDK method instead of the HTTP sort of payload method. I just find this is kind of a personal preference. You can do it either way. The LLM gets the information basically the same way. It's just sort of what your personal preference is. Do you want to package up a little JSON package, or do you want to call it as a function? I'm just a little bit more comfortable with functional type calls. So that's kind of the way I approach things. So in this course, we'll kind of do that. So we loaded the CSV, and our CSV just had the subject and body of incoming support requests. We then use that to call the LLM, and this cell just all it does is detect the language. Actually, I'm going to run these as I go. Let me just clear the outputs. I'm going to run them as we go, so then when we get down to the homework section, we can run those too. Just make sure everything's working. I didn't really set up my local server here, so might take a little minute. So we'll get So here we grabbed a random ticket. So we're going to detect the language. I can see my LLM running. It's loading GPT OSS 20B, which is what we specified as the model to use. So the first time it's going to take a little extra time to load the model. That's almost done. Again, as you remember, if we go up here, you can see that our little function, we have the ability, we can either run against a local model, we can switch and we can run against a model hosted in the cloud very easily. It's basically just changing the base URL and putting in an API key. As long as you're using a model or a server that respects the OpenAI protocol. So Gemini does not, Anthropic does not. Typically you have to use their calling protocols, but they're usually pretty similar. And sometimes that's a good reason for using the SDK wrapper instead of uh, the JSON payload method, because it will the SDK a lot of times will kind of iron out the differences. Okay, so we have our data frame loaded with our tickets. We've got the LLM loaded. We detected the language. So here we sent this. It's obviously German, and it detected German. So that's working. So we'll use the same ticket. We'll send in the body and we'll have it translated to English. So here's the subject line translated, resolve the issue with a high priority Cisco router, then we'll translate the body. Takes a little longer because there's a couple more tokens involved. So here's sehr geehrter Kundenservice, ich wende mich an Sie, etc., and it translates that nicely to dear customer support, etc. So it's doing a nice job translating, very easy. So our first homework was to add a cell to classify the tickets as to the type. Is it an incident, a request, a change, or a problem? So we've got our ticket already loaded. Here's basically, it's just a copy and paste job. All I did was I took the previous cell and I changed the prompt I gave it a system prompt. You're a helpful assistant who's assigned the job of classifying support tickets. I told it to classify the following email into one of the following categories. I gave it the subject and the body, the translated versions. We're going to stick with the translated versions, kind of working through things. And then I just told it your response should simply be one of the following. Everything else is the same as the previous cell. We see again, the translated subject and email, and it classified it as a problem. It seems fair because they said we have an issue with a high priority router. Seems to have figured that out pretty correctly. So for homework 2, same thing, except instead of classifying or categorizing, we want to figure out which department to queue the ticket to. So we have a bunch of different departments. We have we have billing and payments, customer service, general inquiries, human resources, probably an internal thing, IT support, product support, returns and exchanges, sales and pre-sales, and service outages, and finally, technical support. So again, Prestige Worldwide does a lot of different things. We have internal IT support, we have external support, we sell products, which may require support. We charge our customers for our services, so there may be billing and payment issues. So there's a whole host of different kinds of things going on. So again, basically a copy and paste job. We just gave it a different assignment. We gave it some details. We run it. It's going to do the same thing. It's going to take that same English translation and it translates it to, not translates, but assigns it to the technical support queue. Seems fair. It's a Cisco router problem, technical support. of all the possible things, that's probably a reasonable assignment. Then finally, homework 3, same thing, except now we're trying to prioritize it. So we had a bunch of rules we went over last time. These are the business rules that we were given. We didn't come up with these, but the business determined that we have 3 levels of priority. So basically, we just give the LLM these rules. We tell it again that its job is to determine the priority of the support tickets. Then we give it the rules in English. No, nothing fancy. We don't really do anything fancy. The only thing we did was I added if it appears to kind of straddle a couple different rules, choose the lower priority. So then finally determine the priority. We insert the subject in the body, just like we do on the other ones. We run this thing. Lots more tokens this time in the prompt. And it came back with no priority. So it didn't really do a good job here.
So did anybody get, so Tom, I like when I was running this cell and applying this, I got some interesting results. Like it would sometimes choose P1 or sometimes it would choose P1 dash critical. So I had to like be very prescriptive.
Okay. Well, first off, I see my problem. I had been using Grok, so I had the model specified as OpenAI/GPT. That for LM Studio, it's actually different. So I had to change that. That's why I was getting the error. So it wasn't my code, it was my specification of the model. You know, which model were you using, Chris?
I was using that 3 billion instruct
Yeah.
parameter one from LM Studio.
What I found was the smaller the model, the more likely it is to not exactly follow your instructions. And so you'll get kind of weird leakage. It won't, because I'm like, your response should only be P1, P2, or P3, right? And if you use certain models, they just will not follow exactly. And the smaller the model, the more likely that is to be true. So let's see, you were using, let me just check and see what models I have easily available. I don't want to spend a lot of time loading a new model, but let me just look. I know I've got a 3B. So I've got Microsoft Phi Mini Instruct. So let me just load that up real quick. So it's a 4 billion model. We'll see how that does. Let's just grab the exact wording. And I'm going to come over here and I'll plug that into the model designation. So Microsoft Phi 4 Mini Instruct, it's a 4 billion model. The 4 here doesn't mean the 4 billion, it's actually the version number. So let me just run that and see. There you go. See, same problem you were having. It's a problem you're going to run into with smaller models. They just don't have the brain capacity to completely understand these, subtler instructions. So that's one thing we're going to work on in this class is forcing them to follow instructions, even if they don't want to. So the last homework we had was sort of a bundle. Actually, I'm going to go back here and change this back because our next cell kind of depends on a correct result from this one. Okay, we're back to getting the correct priority. So the last one was just, basically bundle everything up into take all the results up to this point, bundle them into one thing. No AI involved. It's just purely constructing a JSON output, instant running. So basically now we have a JSON object that includes all of the things that have been done. So I think, Chris, you and I discussed the 5th item, which was sort of like how long would it take you to decide versus how long did it take the LLM? What did you come up with kind of for an answer there?
I did a sample of like 10 tickets that I went and like randomly chose. So I had to go use Google Translate and translate some of them and then reference the priorities and make some guesses, right? So I averaged about 5 minutes a ticket. And
Wow. Okay.
the model, so I ran a sample, a 10% sample, so like 400 tickets, and I averaged 3.7 seconds. So it was like 81x.
Okay. Well, that seems like a pretty good return on investment.
Yeah,
Um,
yeah.
I mean, assuming they were assigned more or less correctly, but even if there were a few that weren't, it's still a massive saving. So an 81x speed up. And did anybody else get to that point? Anybody else try anything similar? No?
Yeah,
Okay.
yeah, I
Oh,
have
oh,
tried.
go.
Like it is like it is 40% like faster than the like human one. So LLM is faster than.
Okay. Awesome. Well, good. Uh, so I'll just say, what I'm trying to do with the homeworks is kind of steer you towards where we're going next. So if you do them, you're kind of prepared for the next class. So that's just kind of my thought process behind the homeworks. So let's jump into the next phase of things here. So I'll go back to very few slides today, thankfully. So let me go back to this. So we went through the homework. So what we're gonna talk about this week is structured output. So we're actually going to do two things. Number one, you saw that the final output of the homework was a JSON object, and we went through 6 cells, and we each cell did basically one field of the output, and then at the end we manually bundled those into a JSON object that could be then passed to another process. Very, very straightforward. So, I mean, why do we do that? Well, Chris is a good example. He was getting some output that was, let's say, slightly non-deterministic. Uh, Sometimes it would say P1, sometimes it would say P1 critical. Now, just real quick, Chris, did you play with the temperature at all on your
I,
model?
I didn't. I'll be honest. I just went after the P1, P2, P3 designator and put a comma and got rid of the hyphen, and that
Okay.
honestly stopped it.
Okay. So you manually corrected it in a
Yep,
sense. Okay.
just try to be more
Yep.
verbose.
Sometimes you can adjust the temperature. So we touched on temperature, I think maybe class one. Temperature is an interesting thing, and it's getting a little weirder. It used to be that basically if you put temperature at 0, you got a deterministic output. You'd basically get the same answer every time you ran a query with an LLM. That's not so much the case anymore. And in fact, a lot of the models prefer that the temperature be set a little higher. So what is temperature? Temperature is really a statistical measure, and what it means is when we go to predict the next token, temperature will give the model more or less a degree of freedom as to which token to choose next. So the higher the temperature, the bigger the range that it's allowed to choose from. So it what the model is doing inside is it's assigning probabilities to all the tokens that are possible to predict. So there might be 100,000 tokens in the vocabulary, and really what you're getting is, um, you know, all output tokens will have a probability assigned. So there's a couple of other parameters, top P and top K, that can get involved. And essentially what we're doing is using temperature and top P and top K, we can restrict the set of tokens that the LLM can choose from as the next thing that it's going to put out there. So with a temperature of 0, it should choose just the highest probability token every time. But with a higher temperature, it gives it a larger range of tokens to choose from. So occasionally it may choose a lesser token. It still will go kind of by probability, but it won't be so tightly locked down. So if you have a high temperature like 1.0, you might get some pretty creative writing coming out of it. So one way to control some of the output is by setting the temperature extremely low. And what I will say is you need to go and read the model card on Hugging Face or the paper behind the model, because sometimes they'll say that's not a good strategy for this particular model. So GPT-OSS, I think they generally recommend you leave the temperature up around 0.8 and you don't mess with it. You can instead change the top K and top P, which restrict the number of tokens it has to choose from, etc. So there's other parameters you can play with. So temperature is one that you can use to get a little bit more deterministic output. So back to this week's coding. So now we have all the bits and pieces working. We have a notebook where if we step through it, we get an output of exactly what we want, which is the translated ticket assigned to a queue with a category and a priority. So we've got all the bits and pieces working, but it's a little bit awkward. I mean, right now, at least the way things are set up, we'd have to go through our notebook and choose a single ticket and walk through all the steps and finally get a JSON output. So instead, what we'd like to do first is we want to speed up the process. And we want to tell the LLM to do all the work in one pass. So I'm going to hop back over to the to our let's see here. I'm going to hop back over and reshare the coding. And we'll get rid of the notebook. And we'll bring up this week's week 3. All right. So basically, again, I'm going to make sure I've got everything cleared out so we can start up. First part of this is going to be mostly the same. Might have a couple of extra things in here, so check that. What I've done is I've combined a lot of the cells together so that we don't have to click on 900 cells to get where we're going. So we're starting to migrate this to less of a notebook and more of a script. So basically in this cell, what we're going to do, what we'll walk through is instead of doing all the separate bits, we can just combine them into one long script. Now I'm still calling the LLM for each step, right? So we'll just run that and you'll see it's all of the cells just kind of jammed into one. And it's running. So it's crunching through all that. And then at the end, so it took about 13 seconds to run all of these and we get our answer. So that's nice. So that at least we don't have to go through and click a bunch of cells, but we're still calling the LLM 1, 2, 3, 4, 5, 6 times. That seems inefficient. So we should be able to get the LLM to do more of this work for us. So what I propose is we rewrite this into a single LLM call and we ask it to do everything in one shot. So the way, pretty straightforward, we're just going to combine all of our prompts into one sort of mega prompt. So we have our process ticket here. So we're going to give it, we're going to change our prompt. You're a helpful assistant that analyzes and processes support tickets. you must return your response as a valid JSON object, which is exactly what we got up here. So we're telling it to do exactly the same, but we're telling the LLM to do it. We're not going to package it up. We want the LLM to do it. So again, we've got our basic code here. So analyze this ticket, and we're passing in the language name, the translated subject, etc. So here's each field. Detect the primary language, subject translated into English, email body. So these are just the instructions field by field instead of in separate things. Priority, we gave it our rules here again. Then we call the LLM and one-shot this thing. So we'll run this. And so now we have this is our code. So we've defined the function. So we're going to go get our random ticket. Right? Well, I actually assigned it a specific one, so we can do the same one every time. So now it's using this process ticket with all the information. And it returned this object. So it took about the same amount of time as running before, but now it's doing everything in one shot. So we don't have to break things up into multiple LLM calls. We can just have it do everything at once. So so again, we told it what the structure, we gave it the JSON structure that we want. Okay. So we told it, give us the language and language name, the subject and the translated subject. So these are not variables. This is just a structure that I'm telling it to return. Now, if we change the model, if we go back to, let's just see this, we'll do the Microsoft fee for mini instruct. We'll see how that works. Error, 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 error. It's not big enough. It's not smart enough. It doesn't have enough brain neurons to process, or it's just not well trained in structured output. We're not sure exactly. We could probably dig into it, but definitely, it's just not doing a great job here. Now we can also try. Let's see what else. Let's take something kind of a little bit more in the middle. We'll look at Quinn 3, maybe. So let me load up Quinn. Oh, let's try Quinn 4B. That's it's another 4 billion model, but generally the Quins typically do a little better job of following instructions. All right, so Quinn 3, 4 billion, new as of July of this year. And that one did it. So not all 4 billion size models are the same. This is an area where you've got to test. You've got to try different models. Even different providers may provide different Gesundheit. Even the different models are trained differently, and this is generally done in post training. So they're going to either train things to do structured output or not. And again, you can go read the model card. Sometimes it'll tell you that it's good for structured output. Sometimes it won't. You may just have to try it. But here's a really nice 4 billion model. It took 3.4 seconds to do the entire evaluation here. So that's fast. It's efficient. You could run this on your laptop probably pretty easily. It's only 4 billion. And if I look over here, the size that it occupies in memory is only 2.3 gigabytes. So even a laptop with 8 gig of RAM might be able to run this model. So definitely, definitely want to try this. So I took a little bit of an online seminar from NVIDIA the other day, and they were really talking up their Nematron Nano 9B model. Let's see how it does. So it's got to load it, so it's going to take a minute. We'll see. Same ticket. I'm using the same ticket number so we can compare things. Now, Nematron Nano, one of the things it's really good at is agents. So it's been trained on tool use and agent use. So maybe they skipped over the JSON part. Don't know. Well, I do know. You can see right below that what I expect to happen. Um, it looks like it's loaded. One thing I noticed is that when it's running at NVIDIA, it's really fast. When it's running on my LM Studio, Nematron is not fast, and I'm not sure exactly why. But anyway, Nematron didn't do a great job. Again, lots of errors. Now I added one thing I added here is the raw response, so you can see that it's embedding its thinking in the response, which is probably part of what it's choking on. Uh, because we're expecting JSON to come back, and instead we're getting these tokens that indicate, oh, here's my thinking. Well, we don't really want that. So that's an indication. If I go up here, see, we didn't get the raw response back up here because we only get the raw response back if there's an error. So with Quen, we didn't get an error, so we don't see the raw response.
Hey,
that
Tom.
means the JSON. Yeah, go ahead.
I was going to say, quick question. Just coming back a couple of steps to where you were chucking everything in right in one shot. Is there guardrails and a thought process? Let's say that was a way more complicated workflow and I had 200 steps in it, right? And maybe I'm thinking of this, or I'm coming from I'm trying to run something on Snowflake. Do I run it on a small cluster for a long time or a big cluster for a short time? And from an optimization point of view, right? Are there guardrails where you don't do everything in one shot, or what's your thought process there?
It's going to depend a lot on the model, and it's going to depend a lot on the context length. So one interesting thing I ran into, I was playing around with some stuff, and I ran across, I was trying to do some things with a server and it wasn't working. It turns out that, oh, Snowflake, I was playing with this exact stuff on Snowflake yesterday. And for some weird reason, they have their context lengths very short compared to what the model can really handle. So I was throwing stuff like this at it and it was failing. And I went and read their documentation. It's like, oh, for the GPT OSS model, our context length is 8,000 tokens. Well, so here's why that's important. When a model is doing thinking on a complex task, like you throw a bunch of steps at it, it consumes tokens in the thought process. So what it's kind of doing, it's thinking to itself, but those are tokens just like, and then it's resubmitting those as part of its process. So you have to have enough context length. So if you've got 200 steps that are complicated, you're going to probably run out of context. The other thing that I found through lots of experimenting is as you approach a model's context length limit, it starts to deteriorate. Different models deteriorate differently, but there's a definite fall off. And oddly, or maybe by design, what falls off is the stuff in the middle. So you end up with the stuff at the beginning and the stuff at the end of your context is preserved pretty well, but the stuff in the middle starts to get fuzzy. So if you've got a bunch of steps you're trying to do, it could easily get lost. So again, you've got to, it's kind of a case where you got to probably dive into Reddit or something and start looking at what other people's experiences are. And a lot of people say, well, Claude code works great until your context starts to get to about 60 to 75,000 tokens, and then it starts to deteriorate rapidly. So Neil, there's no easy answer. I think it's really experimental, and you're just but like I said, I was somewhat surprised by the same models on Snowflake behaving differently because Snowflake was clamping down on their context length.
Yeah. Okay.
So
And
kind of
I don't know why they're doing that. It's weird to me.
so the inverse. I guess Neil's question is a great question because it made me think about something else. So like I use Grok, XAI's Grok all the time, right? I'm talking to it all the time. After say 20 or so messages, it forgets, right? It starts to forget beginning context. So I
Yep.
wonder too, like,
Same, same exact problem.
it is
Same
this
exact
problem.
problem.
Okay. Okay.
So
Cool.
here the pro tip is if you're let's say you're debugging code or you're doing something and the conversation's starting to go on a long time, like you say, 10 to 20 turns, especially with a thinking model. What I do is I say, write yourself a note summarizing where we are in this conversation so I can come back later and we can pick up where we left off. And it'll write itself a nice note that's fairly concise, bullet points. You just copy that, start a brand new conversation, drop that in and start over. That's the pro tip for keeping a conversation going. If you're using some of the coding models, Claude Code comes to mind. There's actually a meta command /compact, and it'll basically do that exact thing for you. It'll compact your current conversation, clear the context, and start over with that summary. So depends on, if you're just using a chat model, you got to kind of do it yourself. Now, why? It just seems to me it's a lost opportunity why these models don't have a toggle for doing that automatically. I don't understand. I think they have some hubris in, oh, we have a context of 1 million tokens. It's like, nah, there's no model I know of that actually will really do that correctly. The one possible exception is if you're uploading lots of documents. So in the next couple of weeks, we'll get to retrieval augmented generation. But a lot of the models will, if you're uploading documents, they'll actually do a RAG process behind the scenes. So you think you're consuming 1 million characters of context, but you're not really. So that's, it's, I don't know. They're playing some tricks behind the scenes, if you will. Okay, so
Thanks, Tom.
yep. Hopefully that was a coherent answer.
Absolutely.
Okay, so Nematron didn't pass the test. Now, I will say we may use Nematron later when we get into agents because it seems to be highly trained for agentic type stuff. And that may be a new concept to some of you. So we'll work on that. So one of the things we can do is we have a couple parameters. So one of the reasons I like the SDK call is it's a little bit easier to specify parameters into the model. So there's a couple of parameters we can use. We've already talked about temperature, maximum tokens. We can tell it the maximum number of tokens we want you to deal with is 2,000 in this case. That will stop it from generating. Some models get very verbose. The problem is if they are thinking, you may actually truncate their thoughts, kind of in like interrupting your wife while she's telling you to do something. It's not a good idea. Or husband. So a couple things here. We can we can give it a reasoning effort. So depending on what we're doing, we could say this, like translating from German to English, that does not require a lot of thought process in the sense of how LLMs work. So for some of things, we can say the reasoning effort should be low. Generally, again, you may have to look at the model card to find out what things they respond to. The GPT OSS models respond to default low, medium, high, and none, I think. Then we have another thing that some models will respond to called a schema template. So again, if I go back up here, we put this in the prompt. We gave it a schema template in the prompt. We said, please make the output conform to this. Some models do a good job, some models do not. But if they've been trained, we can actually supply that schema template as a parameter rather than embedding it in the prompt. So if we go down here, we'll rewrite our process ticket with schema that'll call.
Is that taking less tokens, Tom, when you do that? When you pass it as a parameter?
I believe so. And I read a couple of the model cards, and what it said is that that becomes a post-process library call. There are JSON formatters out there, and what it does is it takes whatever the LLM outputs and it runs it through kind of a standard Python library to reformat the JSON. There's probably many ways to do it, but my understanding is that for most of them, it's using like pretty much straight code to make sure that the output conforms to the schema given. So here you can see I've changed the AI call to include a reasoning effort and the schema template, and we made our schema template. I'm sorry, this is still the function. So let me compile the function. So now here's our schema template. So we have a ticket schema. The type is JSON schema. We have a name. Now we have properties. We tell it which ones are required, and that's it. Pretty standard JSON type stuff. So run that. And now when we call, we're still using NVIDIA Nemotron, which failed last time. We'll see if we can get it to work better this time. Sorry, I'm giving away the answer. I'm giving away the results here. So remember last time, it returned all errors. This time, by supplying the schema template, we got an excellent response. So, let's back up a second. Why would we want to do this? Well, again, we're trying to think about calling an LLM like a function call. And if we can be sure that the function's going to return a nice format like this, then our downstream work gets a lot easier. We're not looking for a lot of exceptions. We're not trying to reprocess the JSON. We just want an answer. And we want the answer in a convenient format so that we can do the next step of our process. Okay? So another thing that can come with the JSON formatting is we can get some extra stuff. So let's back up again a little bit. Let's see, this is from, I think this is from Grok. This is their price for different models. Let me see. No, this is, I'm sorry, this is Open Router. So if we're using a big model, or we're using, if this is for Viore, we need to pay. They don't mind hobbyists, but if we're crashing millions of tickets against this thing, and they're going to make us pay. So what does payment look like? So if we're looking at a pretty serious model like GPT-4o Mini, 15 cents per million input tokens. Now input tokens are our prompts. And 60 cents per million output tokens. And here's our context length. Qwen 72B, I'm sorry, Qwen Plus. Actually, I'm not sure what size that is, but it's got 1 million context length, 40 cents input, $4 output. So some of these can get fairly expensive, especially the thinking models. So if you're using a lot of thinking models, those are going to be a lot more expensive. I think GPT-5 in thinking, it's like $6 a million, something like that. If you're using a lot of thinking, you can easily, every call, like if we're doing 4,000 tickets, that could easily be millions of tokens. So, a couple bucks here, a couple bucks there, pretty soon it adds up. The other issue, though, is there may be rate limits. So this is from Grok, and these are their free models, but they're free, but they do have rate limits. So I think Chris, you were looking at maybe Llama 318B Instant, which is a very fast model. You can only do 30 requests per minute and 14,000 requests per day. And then they have tokens per minute, tokens per day. So if you're trying to use some of these models and doing your homework and you're getting weird answers, or things start to error out after a while, you could just be running into a rate limit. So you need to put some error checking into your code just in case you're hitting rate limits, especially these are much more important if you're using free models. Okay. So I added a little code here so that it will actually, basically it's the same, our call LLM SDK, but I asked it to return the number of tokens consumed. So everything's identical, except in our ticket data, it's going to return token usage as well. So it's going to return prompt, completion, and total. So let's use Grok real quick. And we can run our sample here. And I put in you can see how fast Grok is running. It's doing a ticket every 1.3 seconds using Llama 8, Llama 8B. But you'll notice one thing, after a little while, it starts to slow down. So I think in addition, excuse me, in addition to rate limits, after so many rapid fire turns, it starts to kind of slow down a little bit, and you start to see the first 10 or the first 8 went at about 1.5 per second. Now all of a sudden it's like 7, 8 per second. All right,
and
7,
I
8.
thought it was the difference between translating and non-translating, Tom. I'm glad you're showing this.
Yeah. So yeah, I mean, I haven't really run into too many like online lessons that discuss some of these subtleties, but if we're talking about moving something into production, which is our, kind of our end goal, we want people to use this, right? um, if we're talking about moving things into production, we really need to think about this stuff. So I'm going to kill this because this will take a while. Let me go back and instead let me switch over to LM Studio locally, back to my Qwen 4B model, which we know worked pretty well. So I'm just going to run this. Now, in theory, so we're getting, roughly the same performance, about 2 seconds per iteration, but this should not slow down like Grok did, because on my LM Studio running locally, I don't have any throttling. I think we're getting throttled by Grok. And I think that makes total sense. If we're using Uncle Elon's free services, it's totally within his rights to kind of slow us down if we're pounding it a little too hard. But you can see we're already up to 20 out of 50, and we're still right at about 2 seconds per ticket. So very nice. And if we were on a paid Grok plan, I don't think we'd be getting throttled. So same with Open Router, you can pay, get on a paid plan, and even using the free models, I think they take the throttles off. So it's, nothing in life is completely free. So this is still maintaining somewhere between 2 and 2.5 seconds per ticket. So that's good. We're about 80% done. Just, pro tip, this TQDM is what's doing this little progress bar. Always a nice thing for users to show them your progress. So it's a nice little feature to throw in on anything that's going to run for a while. All right, 98, 100%. All right, so we generated almost 40,000 prompt tokens. Our completion tokens is way down because the Quen model's not thinking, and it's only returning this JSON payload. It's not returning a whole bunch of text. So our total tokens about 50,000. Average per ticket is about 1,000. So now we've got some test data. Now we know we can generate all this stuff. It's going to cost us around 1,000 tokens per ticket if we use a simple model that works fine. It's a small model, doesn't generate a lot of jibber jabber while it's thinking. So that's kind of where I wanted to end for today. Talk a little bit about homework. But first, any questions up to this point? I think with this notebook, this will be in the Git as soon as class is over. I'll push this up to the Git. So any questions? Okay. Ask any time.
I was just gonna say, Tom, thanks for covering that last bit, right? Any other videos you go watch, and it's theoretical. Nobody talks about running it in the real world and what it costs. So it is so critical to have that as part of your thought process right from the start.
Yeah, and I think as part of this class, since not all of us, but many of us are using Snowflake, I've been looking at that guy's repository and converting some of this stuff over to run in Snowflake. And so I'll be able to get some ideas on Snowflake has a SQL query you can run that says, tell me how much I've spent so far on AI services. And after running a few of these, I should be able to get some notion from Snowflake itself what the cost is. But yeah, putting stuff into production, it's not only a matter of getting it to work. It's also a matter of how much is it costing. So if we find out, well, it's costing us $8.3 million a year to automate our ticket system, maybe we should just hire a few more people. We could easily, and it would be better for the economy to put some people to work. So our homework for next week, run the process model, try some different providers, make sure the JSON is returning correctly, and I'm uploading a CSV with just 100 tickets in it, so you can just use that. The difference is that CSV also has the assigned category, priority, etc., so that you can run your stuff against that and see how you match up against what the humans assigned. So add your stuff to that data frame, and then you can do a quick statistical comparison of how many matched up correctly, the queue, the category, priority, and then in the CSV also you'll see the answers. That's that second part. So then using those same samples, give a try to automatically answering the request. Use an LLM and say, here's a request from a user, here's the subject, here's the body, here's the priority, here's the queue. Do your best to answer this. See what you can do. I'm curious to see what kind of answers the LLMs will give. Next week, what we'll do, we'll take a look at what those look like, and then we'll forget about the class schedule and kind of modifying on the fly. I think what we're going to do next week is work on answering the tickets, because that's actually really interesting. And we'll look at a couple different ways we can answer the tickets automatically. We may spend a couple weeks on that because there's a lot of different techniques we could use to auto answer the tickets. So that's the homework for this week. We're ending right on time. I'll hang around for a couple minutes. You know, if anybody has any further questions, please let me know. Otherwise, I'll push this to the Git and you guys can start on the homework. Don't ignore your real job. I know this is so exciting, you'll be tempted to not do real work, but you know, make sure you get your regular work done. Any other questions, guys? Otherwise, we'll see you next week, same time, same channel. And I look forward to seeing your results. Remember the Discord. Yeah, remember the Discord. Make sure to sign up for the Discord so we can carry on the conversation. And ask any questions there. Probably the easiest place to ask questions. So, all right, I'll go off and push the week 3 stuff up to the GitHub, and we'll talk to you next week.
Thanks, Tom.
See you on the Discord. Ciao.
Thanks, Tom.
Thank you, Tom.
Bye.
Bye, Tom. Thank you.